All right, how do we graph a rational function by hand? Now, it's not going to be perfect, okay? So it's going to be more of a sketch, an overall sketch with, maybe 4 decent points or something like that. But the main idea is we're going to get our asymptotes to guide us, okay? So remember, step number 1 is to factor. All right, so I'm going to do x and x. Factors of 10, 5 and 2 are going to give me my 3. I want a positive 3, so I want my positive loopy on the 5 and my negative here. You can see x squared's there, 5x negative, and negative 10. I'm good. On the bottom, in my denominator, I have x and x. Factors of 15 that give you an 8 are 5 and 3. Everything's positive. And again, you can check your loopies first. Outside, inside is great. Okay, so that's step number 1. Okay, first, remember you look for holes, okay? Because holes can be hidden and you might think, oh, I have vertical asymptote at a -5. No, you don't. There is no vertical asymptote at a -5. So you have to look for holes first. Okay, so holes are when things cancel out because technically you're assuming that you're not like 0 divided by 0 is a no-no. So you can't cancel, things that are no-nos. So we need to, yes, we're going to cancel those, but we are going to say, okay, well, x cannot equal a -5. So there's going to be a hole in our function at a -5. Now, when you have a hole, then you get a new function. I'm going to call it n of x because this is my new function that I'm going to look at. I can't go back and look at this for, verticals because I'm going to think that -5 is a vertical and it's not, it's a hole. Okay. The other reason you need your new function is because you have to sub this into this to figure out the y value of your hole. And again, that is paint under my nail. All right. So I'm going to sub in a -5. -5 minus 2, -5 plus 3. And again, remember a lot of pre-calc is about subbing in input to get output. We do that a lot. So -7 over -2, that's 3.5 or 3.5. All right, so there is going to be a hole on my graph there. Okay, now check, we're done with that. Next is vertical asymptotes. Okay, this is dealing with input. So that we're looking down here, a -3 causes problems because I'd be dividing by it, right? So x equals a -3, that's the formula of a line, okay? That's not a point. This is a point, this is a line. Is going to cause problems. Okay, so we're going to have a vertical asymptote there. Check. Next thing you do is look for horizontals, slants, obliques, what other words? It could be a parabola, parabolic shape. We're looking for the horizontal asymptotes and all those other weird ones. Okay. So here it really doesn't matter which one you look at because your leading coefficients, do you see how those cancel to 1? X squared and x squared cancel, leaving you 1. But your new one does it too. So do you see if you look at your leading coefficients, x divided by x gives you 1. So, and again, this is dealing with output. So this is a horizontal asymptote. Okay. So now what we're going to do is we know that our graph is going to kind of be hemmed in and all these. Also know horizontal are suggestions. Doesn't necessarily mean it's an asymptote for everything. All right, so let's graph what we have so far. So I'm going to make my XY axis. All right, so let's see, -5. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 4, 5, 6, 7, and 1, 2, 3, 4, 5, 6, 7. Okay, I'm going to do my whole first. I'm going to go back -5. So 1, 2, 3, 4, 5, up 3.5. So about right there. And I'm going to put a hole so I don't forget it. All right, x -3 is vertical. So 1, 2, 3. Okay, that's a vertical. Horizontal's at 1. Okay, so now I know that this thing is for sure over here, right? Usually, and there are ways to tell by looking at kind of end behavior, but I don't know how important it is in the real scheme of life, but some people might not agree with me. But anyway, regardless, is I know it's going to be over here, and they tend to be like this, maybe here, right? So I'm going to test some points in here to get the overall shape. But again, do you guys get, I can pretty much kind of draw it already. And then I'm going to get some points over here. Now notice finding your y-intercept would be a good idea, and your x-intercepts would be good ideas. And if you have them, right, because obviously, you know, we don't have any asymptotes on, like, for example, we don't have an asymptote here and we don't have an asymptote here. So, you know, it could cross. And again, remember, vertical lines are brick walls, no crossing. Horizontal can be suggestions. They might just be for part of the graph, not all of the graph. Okay, I'm going to make an input-output chart here and sub in some numbers over here and over here, you know, so we can get a feel. But I'm going to pause for a second to do that. All right, let's look at our new function for these guys. So remember, if you sub in x, you get, or 0 for your x, you get a number for your y. That's your y-intercept. So sub in 0, 0, and 0, you get a negative 2/3. So that's your y-intercept, 0, negative 2/3. Okay. Now on the other end, if you put a 0 in for the y, you're getting something that lands on the x-axis. That is an x-intercept. Now this is output, so I'm going to put it over here. Now, a lot of times your homework might just say set this equals 0. And the reason is 0 divided by 8, 0 divided by 10, 0 divided by 4. It doesn't matter what the denominator is. If the numerator is 0, all of it's 0. The reason that works also is because if you solve this equation, do you see how 0 times anything is 0? So you end up getting this. So either way, we want to know when the numerator is 0. So add 2, x is what? 2, okay? So when it's 2, it crosses there. All right, so let's just plot those on there. So we know 0, negative 2 1/3. So 0, negative 2/3 is about there. And what else did we do? 2, 0, so 2 on the x-axis. Okay, now personally, that's enough for me to get the shape, okay? Because we're just sketching it. Do you get that this is gonna, you know, we're gonna kind of block it, but let's kind of see if what's going to harm here, because maybe, you know, maybe this is a suggestion for this guy, or maybe it's a suggestion for this. So what I did is I subbed in -1, and I got -1.5. So I just picked numbers to sub in to my new function. What else? At 1, I'm at a negative 0.45, so that seems to make sense. At 2, I'm at 0. Okay, now I could sub out here because I might be like, what is happening here? So let's look. 1, 2, 3, 6, 7. Let's sub in 8 and just see. If I sub in 8, I get 8 minus 2, our numerator. And if I sub in 8 here, I get 8 plus 3 is 11. So what is that? 6 11th. So I'm, you know, I'm above there. So my overall shape is right there. Okay, now let's look at this side. This is the one with the hole. Now again, it's still going to be one of these curvy kind of guys, but so where's my hole at? That was -5. Okay, so -6, I'm at 2 2/3. So 1, 2, so about, I don't know, somewhere in there. At a -4, 1, 2, 3, 4, I'm at 6. All right. So again, kind of gives me, you know, an overall feel, you know, for what is going on. Okay. Now let's graph this on Desmos, you know, see how good we are. Now, again, I could go way out here and sub in a -20 just to kind of see what's happening over time. So I could do that. All right. But let's look at Desmos to see. All right, I went ahead and graphed the original function. Now notice on the original, if I go to -5, if I can, maybe, oh, come on, Julie. There we go. It should say undefined because that's your hole, okay? That is your hole. So it's kind of hard to see, obviously, on Desmos because do you see how it does a solid dot? But when you get to, and again, if I can do it again, that would be amazing. -5, come on, Julie. Oh, I had it for a second. There we go. Do you see how even Desmos does an open dot for it because it knows it's a hole? Okay, now what I'm going to do is I'm going to go ahead and plot in our new function. Okay, so what was that? X minus 2 in the numerator, and what was my denominator? X plus 3. And you are not going to see anything, okay? If I hide it, There's the original. They're going to look identical. The only difference is that this one, if you go to 5, it's defined because you're not defined by 0. So you have to know that these two things look the same. The only difference is this one, obviously would not have a hole there because you canceled out the problem, but this one does. So even though when you graph it, you graph this, you need to know that you really canceled out that -5, and that's where that hole is. So there you go. Okay. All right, let's try another one. Okay, let's start this one. So first of all, I factored. Check perfect square minus perfect square is when you have the difference of 2 squares. So x minus 2, x plus 2. Nothing canceled. So guess what? No holes. Look at the denominator. Set those equal 0. So that your shift there is 2, shift there. Both of those cause dividing by 0. That's a problem. Those are going to be asymptotes, vertical. Horizontal, slant, oblique, whatever. Okay, look at your leading coefficients. 1 divided by x. If you sub in a huge number for x, like 1 over a million, 1 over a billion, 1 over a trillion, you end up going towards 0. So y equals 0 is that, okay? So what I'm going to do is I have vertical asymptotes at 1 is at 2, 1 is at a -2, and the other one is horizontally here, which again, remember, these are brick walls. They can't cross. This is a suggestion. Okay. So the next thing that would be a good idea is to find x-intercepts, y-intercepts, and then sub in some values over here, see what's happening, sub in some values in the middle, see what's happening, sub in some values over here, see what's happening. Sometimes it's like this and this, this and this. Sometimes it's more of a kind of a U or parabola looking thing in the middle. Sometimes it's kind of that snaky looking, kind of like a cubic looking type thing. So let's figure this out. Okay, so go ahead and try to find your x-intercepts, y-intercepts, and some points in the region. And again, if you have 2 or 3 points in each region, you can kind of, figure out what's going on. So you don't need tons and tons of input and output. All right, I'm going to pause. You do it while I do it, and then we'll compare. Okay, I probably did more work than I normally would do, but, it's a video, so I'm probably going to do that. Subbed in input, got output again, subbing it in. So when x is 0, 0, 0, do the math, okay? When y is output, again, really all you have to worry about is the numerator equaling this because the denominator will cancel, and I got that. All right, so then the other things I'm like, okay, let's test some points over here to see what happens, some in the middle, so like -1, 0, 1, and then some to the right to see what would happen. And again, all you're doing is subbing input into this thing and getting output. So I did it kind of on the left side, the middle side, and the right. All right, so let's plot some of these points. Now, I would probably do these first. So we know the y-intercept is what, up at a 4th? And we know the x-intercept is at 1. All right. So then let's sub in, let's look at the middle. At a -1, I'm at what? 2/3? All right. So we might want to sub in, it looks like it's going to cross, but like if I wasn't sure, does that make sense? I could sub in 1.5, but this is looking like it's going to do that. Okay, and that's pretty common. All right, let's look on the right at 3. So 1, 2, 3, I'm at what? 2/5. And 4, I'm at a 4. All right, so this side, again, not very good at drawing, but is everyone okay? That's, what's happening over there. And then let's look at over here. -5, I'm in negative. So 1, 2, 3, 4, 5, negative. -4, it looks like negative. And -3, more negative. So this one is kind of hemmed in between those asymptotes. All right, everyone okay? I got that. Okay, I'm going to pause and graph it on decimal so we can double check. All right, here you can see the graph. And if I plot my asymptotes, you can kind of see where those are at as well. All right, I want to talk about quick if this were an inequality. So I'm going to pause and we'll chat about that quick. Now, if someone gave you this as an inequality, do you see how they're saying when is it positive? So your output is positive up here, -2 to 1, because not including the asymptote and including the 1. pick up on the other side. And then do you see how this gives you positive output? So with inequalities, you can look at that graph and you can do that, or you can